This is Mr. Navi from Roger Bacon High School. Today's lesson for Algebra 2 is on completing the square. I'd like you to read through the poem that I've got pulled up here. Its title is 99.9% Good Enough. So please pause the video. When you're finished reading, come back to the video. You should have read through the poem here. The point that I thought was the most interesting was if 99.9% were accurate enough, then every day 12 newborns would be given to the wrong parents. Sometimes 99.9% is sufficient, other times it's far short of sufficient. So what does this have to do with quadratic equations? Well, if you're given this quadratic equation, y equals negative x squared minus 3x plus 8, you realize that you can't factor it. If we were able to factor, we'd be able to find the roots, the zeros, the x-intercepts of this graph by setting it equal to 0. Since we can't factor it, our next alternative is to look at the graph. And as you study this graph, you might say that it seems the x-intercepts occur at about 2.5 and about negative 5. If I were to zoom in, though, on this graph, you would actually notice that these intercepts occur at about 1.7 and about negative 4.7. Doing a quick error calculation, 1.7, the actual value, divided by our initial guess of 2.5 as one of the roots, is actually only 68% accurate. There's a lot of error there. Even on the other side, our guess was negative 4.7. Excuse me, that was the actual value, divided by our guess, which was negative 5, that's actually only 94% accurate. Both might work in some cases, but in certain contexts, 68% and 94% accuracy wouldn't be sufficient enough. So what do you do in those cases? Well, you'll use a method known as completing the square to find the exact values of where the graph would cross the x-axis. Here are 3 examples that I'd like to start looking at. If you factor the first one, you get x plus 4 times x plus 4. If you factor the second one, I left off a 3 there, x squared plus 4x plus 3. If you factor the second one, you get x plus 3 times x plus 1. And for the third one, actually, there are no factors that we can find that factor into 2 binomials. So we have to have an option of how to solve that if we can't factor it. Going back to example 1, since the factors were identical, you could actually write it as x plus 4 quantity squared. This is known as a perfect square. This is why we call the process completing the square. Our goal is to create a perfect square. In example 2, you realize that the factors are not identical. This would not be a perfect square, but you can still create a perfect square. And let me show you how. If we have our original example again, x squared plus 4x plus 3, the first step that I want to do is isolate the x terms. I want to transform the x's into a perfect square. So I'm going to have to add some number to the right side of the equation to make it a perfect square, because I know that eventually I have to get to something quantity squared to make it a perfect square. Well, if you just use a little logic here and you ask yourself, well, what times what will give me x squared plus 4x plus some other number, you realize the middle term has to be sum of 4x. Well, the only 2 factors that are identical that'll add up to 4 are 2 and 2. So this value must be 2 squared. Or you could write 4. I'm going to replace that with 4. Now you have x plus 2 times x plus 2, or x plus 2 squared. What we did here was we added this term. We added this term to the right side of the equation. And you know just as well as I do that you can't add a number to one side of the equation without also adding it to the other side. So in order to keep the equation balanced, we actually have to add 4 to the left side of the equation as well. We've got to keep the equation balanced, so it needs to be added to both sides. Okay, we've got a perfect square now. Now let's come over to the third example. We will isolate the x terms, and I actually want to do one more simplification here. I want to do one more simplification just to make it a little bit easier for us to solve. What I did was I factored out a 2 because both of these x terms have a common factor of 2. So I bring the 2 out front, and now I've got an easier problem to deal with. So I have to add some number inside here that makes this term a perfect square. So if I think about that for a minute, I've got to have a value here that when I multiply it by itself, those factors will add up to 2. Now the only two factors I can think of that are the same, that add up to 2, are 1 and 1. So 1 times 1 is 1 squared, or 1. So now I have a perfect square, x plus 1 quantity squared. And remember, whatever you add to one side of the equation, you have to add to the other. And we didn't add 1 only to this side. In fact, we added 2. Let me explain. We factored out a 2 originally, so even though we've got a 1 inside the parentheses, we then have to distribute the 2 times x squared, 2 times 2x, and then 2 times the 1. We actually added 2 to that side. And we can simplify from there. Okay. Now, we started talking about the process of completing the square because we wanted to be able to find the x-intercepts. You know that x-intercepts occur when y equals 0. Let me write that down. X-intercepts occur when y is equal to 0. So if I let y equal 0, I have 0 plus 1 equals x plus 2 quantity squared. So 1 is equal to x plus 2 quantity squared. To simplify or to solve for x, I need to get rid of the squared so I can actually take the square root of both sides. Now the square root of 1 actually has two answers, plus or minus 1. The square root of 1 could be positive 1 because 1 times 1 is 1. Square root of 1 could be negative 1 because negative 1 times negative 1 is also 1. So there are two possibilities there. And to solve for x, I'll then subtract 2. So it could be negative 2 plus or minus 1. Now, if x, I have two answers for x here. Negative 2 plus 1, which is negative 1. That's one of the answers. Or negative 2 minus 1, which is a negative 3. That's the other answer. Now, these two answers we've seen before. If we come back up here to the problem in the box, we had x plus 3 and x plus 1 as the factors. Well, what makes this term 0? Negative 3. What makes this term 0? Negative 1. So completing the square is going to yield the exact same answers as if you factored. But again, example 3 shows us that you can't always factor. You can't always factor. So we've completed the square here. Let's solve for the x-intercepts. We've got 0 minus 5, that's negative 5, is equal to 2 times x plus 1, quantity squared. I have to divide both sides by 2, so that the 2's gone there. So this is negative 5 halves equals x plus 1, quantity squared. Now I'll take the square root of both sides. The square root of both sides. And here we have a problem. The problem is you cannot take the square root of a negative number. So at this point, we know x has no x-intercepts. There will be no x-intercepts here because we have no solution. There is no place that this graph will cross the x-axis. Okay? So that's the process of completing the square. What I'd like you to try now are these three problems from page 260 out of your textbook. Take a few minutes. At this time, pause the video and try these 3 problems. When you have finished, unpause and I'll show you the solutions. Okay, you should have finished with these 3 problems. Let's take a look at the answers. First step in every problem is to isolate the x terms. So I add the 8 to both sides to bring the 8 to the right, and x squared plus 2x plus some number is equal to 8. So what I do is I do x squared plus 2x plus 1, and I add 1 to the other side as well, add 1 to both sides. I've now created a perfect square. This term right here is a perfect square because it factors into x plus 1 quantity squared, and 8 plus 1 is 9. To solve for x, we took the square root of both sides. Square root of 9 is either positive or negative 3, could be both, because both 3 times 3 is 9 and negative 3 times negative 3 is also 9. And then we subtract 1, and the possible answers are x equals negative 1 plus or minus 3. So if it's negative 1 plus 3, the answer is 2. If it's negative 1 minus 3, the answer is negative 4. So either of those 2 values would be where the graph crosses the x-axis. In example number 9, x squared minus 4x plus 9 equals 0. Bring the 9 to the right side by subtracting, and I've got x squared minus 4x. I have to add some number to complete the square, to create a perfect square. And here's my perfect square. X squared minus 4x plus 4. 4 is that number that I can add to both sides to create a perfect square on the left. The perfect square is actually x minus 2, quantity squared, because that's what it factors into. The right side, negative 9 plus 4 is negative 5. At this point I can take the square root of both sides, but I have a problem, because anytime I take the square root of a negative number, there is no real answer for that. So that is no solution, which the interpretation of that would be that the graph will not cross the x-axis. In example 10, this one's a tricky one. I add 3 to both sides to isolate the x terms, and I actually want to simplify this problem. I simplify it by factoring out a 2, so that this leading term is x squared. So bring the 2 out from both of those terms. And if I take a 2 out of negative 3, I actually have negative 3 halves, because 2 times negative 3 halves is negative 3. Now, I want a perfect square. This one is a tricky one, but I actually realize that if I add 9/16 to this term, I've created a perfect square. The reason is, and this is true for all the examples we've done today, if you take half of this term in the middle, half of that middle term, and square it, that gives you the term you need to add. Let's go over here. Half of this middle term is negative 2. Square it gives us 4. Let's come over here. Half of the middle term is 1. Square it gives us 1. So anytime you're trying to complete the square, you will take half of b, whatever that middle term is, and square it. This is the key. This is the key. Half of b and square it. And that's what you'll add to both sides. So when I write this as a perfect square, what times what gives me 9/16? Well, it's actually 3/4. So this factors into 2 times the quantity x minus 3 squared. And the way I got 33 over 8 is 3, if I get a common denominator of 8, is actually 24 over 8, and 24 and 9 is 33. So 33 divided by 8 would be the numerical value, the fractional value of those 2 numbers added together. And then we can solve for x by dividing by 2, so that gives me 33/16. Taking the square root of both sides gives me plus or minus the square root of 33, and I actually know the square root of 16, so I can just write that as 4. And then x minus 3/4 is plus or minus the square root of 33 over 4, which means x is going to be equal to 3 plus or minus 33 over 4. 2 possible answers there. Okay? So the homework is on the board. You can check that out. Use the textbook from lesson 4-5 in our book to kind of assist you if the video left out some things that you weren't sure on. So use all the resources you can and complete the assignment. Thank you.